Okay, it's recording now. And this is a math project by me, Tian, and
Myself, David. We are doing number 25 on page 67, which is an area bounded by the equations y equals 2x, y equals 0, and x equals 1. The moment around the x-axis is found by the equation shown in the top left corner, which is rho, or the density, times by 1/2, multiplied by the antiderivative of the equation f of x squared minus g of x squared. So for now, we're going to plug in the equations that we have, which is rho times 1/2 the integral from 0 to 1 of 2x squared minus 0 squared. If we simplify that, we get rho times 1/2 times the integral of 4x squared. Simplify this again, where we pull the 1/2 into the integral, we get rho times the integral of 2x squared. Integrating, we get the moment around the x-axis is equal to rho times 2/3 x cubed integrated from 0 to 1. Solving this out, we get that the mass around the x-axis is equal to rho times 2 over 3 multiplied by 1 minus 0, which is the same as 2/3 rho. So the moment around the x-axis is equal to 2/3 rho. The mass of the curve is equal to rho times the integral from 0 to 1 of 2x. If we integrate this, we get that the mass is equal to rho multiplied by 2x from 0 to 1. And if you plug in 0 to 1, you get that the mass is equal to rho.
okay, and this is how the graph would looks like. The blue line represent the equation 2x, and the graph is bounded by the y is equal to 0 and x is equal to 1. To find moment of y, you use my is equals to rho times the integral from a to b, which is 0 to 1 here, times x times f of x minus g dx. And we just plug in our functions, which is 2x, into the f of x and minus 0. And then if we simplify and integrate it, we will get 2px cubed over 3. And then if we just plug in 1 and 0 for x, we would get 2 rho over 3. And these are the equations in order to find the center of mass. You got your area, which is the integral from 0 to from a to b of your function x, and the center in x, which is 1 over the area, times the integral from a to b of x f of x minus gx, and then the center of y is 1 over area times the integral from a to b 1 over 2 times f of x squared minus g of x squared. And this is to calculate the center of mass. And if we integrate the area, which is 2x, we get 1 as for our area. Using that area, we plug it into our center of x, so which is 1 over a, which is 1, times the integral from 0 to 1, x times 2x minus 0, since g of x is y equals to 0, which is 0. And then if we simplify it, we would get 2x squared. And then if we integrate, we get 2x to the cube over 3. And then if we plug in 0 or 1 and 0, we get 2 over 3 for the center of x. And for the center of y, we would do the same thing, which we just plug in the area, which is 1 over a. So 1 over 1 times the integral of 0 to 1 times 1 over 1 times 1 over 2 times 2x squared minus 0. And if we simplify it, we will get y is equal to 1/2 the integral from 0 to 1, 4x squared. And then if we just take out the 4, it will simplify to 2 times the integral times x squared. And then when you integrate it, you just get 2 times x cubed over 3. You plug in 1 and 0 for x, and then you would get the final answer of 2/3. So the center of this graph would be located at x is equal to 2/3 and y is equal to 2/3. And that is it.